Although outer space begins at the height of 100 kilometers from sea level, going there means one is working against gravity, and precise mathematical calculations are needed. The problem with traveling to space is that it involves going up the whole way, meaning one must fight gravity throughout the distance. Astronauts, through mathematics, compute how a spacecraft departs from the Earth's atmosphere to how they pilot the rocket. When building spacefaring vehicles, designers use math in calculating the velocity, distance, and safety when flying the machines. Mathematics helps astronomy students learn how to look for correlations and trends in data. The course teaches them how to work on very small or large numbers using scientific notations, use scale drawing techniques to estimate an aurora's size, calculate the magnetic field strength, and change raw data to physical quantities using simple equations. Scientists should track various types of phenomena both in the Earth's atmosphere and space. Therefore, they have invented a method of writing minimal and big numbers using scientific notations. Moreover, they have to think in 3 dimensions and use mathematical models to better predict, for instance, what to do when the next solar storm arrives on the Earth. Astronomers use decimal numbers in measuring processes or objects in space. The aforementioned activity utilizes POES satellite data from the National Oceanic and Atmospheric Administration to link the Northern Lights displays with reference to how many energy watts they produce. In addition, scientists manipulate different classes of measurements to track sunspots, which signify that the sun is in a stormy condition. In extreme circumstances, these storms are likely to affect the Earth, leading to problems like electrical power outages, satellite damages, and cause harm to astronauts working in space. Scientists create and use several kinds of equations in quantifying data and making predictions. For instance, they use a scientific theory to describe how quantities should be logically related to one another and derive a mathematical process of operating with nature symbolically. Data from the image satellite that orbits the Earth and views the southern and northern lights from outer space can be used to measure the auroral oval diameter and its changes during an occurrence of a solar storm. The measurement is significant because as the solar activity decreases and increases, the aurora's size increases and decreases, respectively. Recent advancements in computation and mathematics have led to various fuel-saving and mission-enabling ways in space that could not have been found otherwise. Contrary to people's daily experience in life, the most effective path through space is not a straight route. NASA engineers, together with some mathematicians, have established that to save fuel and, at the same time, take advantage of gravity, it is crucial to make bizarre loops in space. The interplanetary probes design in space utilizing the competing gravitational tugs of the various planets and the Moon could not be reached without mathematicians. The aforementioned advancement creates an extensive network of passages where a spaceship can expend minimal energy to travel for long distances. Therefore, to be an astronaut at NASA, a degree in a mathematics-related course, such as engineering, physical science, is required. StudyCorgi.com has everything you need for successful studies. Writing tools, informative articles, and essay samples. Come check it out.